Mars and Its Canals by Percival Lowell, Chapter 3. A bird's eye view of past Martian discovery. With Mars, discovery has from the start waited on apparent disk. To this end, every optical advance has contributed from the time of Galileo's opera glass to the present day. For apparent distance stands determined by the size of the eye, but although it is the telescopic eye that has increased, not the distance that has diminished, the effect has been kin to being carried nearer the planet, and so to a scanning of its disk with constantly increasing particularity. Mankind has, to all intents and purposes, been journeying Marsward through the years. Any historic account of the planet, therefore, becomes a chronicle of seeming bodily approach. Perhaps no vivider way of making this evident, and at the same time no better preface to the present work, could be devised than by putting before the eye, in orderly succession, the maps of Mars made by the leading areographers of their day, since the planet first began to be charted 65 years ago. The procedure is as much as possible like standing at the telescope and seeing the phenomena steadily disclose. Seen thus in order, the facts speak for themselves. They show that from first to last, no doubt concerning what was seen existed in the minds of those competent to judge by systematic study of the planet at first hand, and furthermore from their mutual corroboration, that this confidence was well placed. For, far from there being any conflict of authorities in the case, those entitled to an opinion in the matter prove singularly at one. Beginning with Maedler in 1840, the gallery of such portraitures of the planet comprises those by Kaiser, Green, and Schiaparelli, continued since Schiaparelli's time by the earlier works of the present writer. To this list has been added one by Flammarion, which, though not solely from his own work, gives so just a representation of what was known at the date 1876 as to merit inclusion. The remarkable drawings of Dawes and the excellent ones of Lockyer in 1862 to 1864 were never combined into maps by the observers, and though the formers were so synthesized by Proctor in 1867, the result was conformed to what Proctor thought ought to be, and so is not really a transcript of the drawings themselves. Each of the maps presented marked in its day the point areography had reached, and each tells its own story better than any amount of text. They are all made upon Mercator's projection, and omit in consequence the circumpolar regions. The later ones give, too, only so much of the surface as was shown at the opposition they record, for Mars, being tipped now one way, now another, regards the Earth differently according to its orbital position. In comparing them, therefore, the equator must be taken for medial line. Mercator's projection has been the customary one for portraying Mars, except for such oppositions as chiefly disclose the Arctic pole, and this too with a certain poetic fitness, for it comes by right of priority to delineation of a new world, seeing that Mercator was the first to represent in a map the mundane new world in its entirety, by the rather important addition of North America to the southern continent already known, and to give the whole the title America, with Ame at the top of the map and Rica at the bottom. In looking at the maps, it is to be remembered that they are what we should call upside down, south standing at the top and north at the bottom. Inverted they show because this is the way the telescopic observer always sees the planet. The disk would seem unnatural to astronomers were it duly righted. Just the same do men in the southern hemisphere look at our own Earth topsy-turvy, according to our view, the sun being to the north of them, and the cold to the south. Certain landmarks distinguishable in all the maps may serve for specific introduction. The V-shaped marking on the equator pointing to the north is the Syrtis Major, the first marking ever made out upon the planet, and drawn by the great Huygens in 1659. The isolated oval patch in latitude 26 degrees south is the Solis Lacus, the pupil of the eye of Mars, while the forked bay on the equator, discovered by Dawes, is the Sabius Sinus, the dividing tongue of which is the Fastigium Arin, has been taken for the origin of longitudes on Mars. 12 maps go to make the series. They are as follows. 1. Map of Beer and Maidler, dated 1840. 2. Map of Kaiser, 1864. 3. Map of Flammarion, Resume, 1876. 4. Map of Green, 1877. 5. Map of Schiaparelli, 1877. 6. Map of Schiaparelli, 1879. 7. Map of Schiaparelli, 1881. 8. Map of Schiaparelli, 1884. 9. Map of Lowell, 1894. 10. Map of Lowell, 1896. 11. Map of Lowell, 1901. 12. Map of Lowell, 1905. If these maps be carefully compared, they will be found quite remarkably confirmatory each of its predecessor. To no one will their inter-resemblance seem more salient than to draftsmen themselves, for none know better how surprisingly, even when two men have the same thing under their very noses to copy, their two versions will differ. Judgment of position and of relative size is one cause of variation, focusing of the attention on different details another. What slight discrepancies affect the maps are traceable to these two human imperfections. Maps 4 and 5 make a case in point. It was to his newfound Canals that Schiaparelli gave heed to the neglect of a due toning of his map, while Green, less keen-eyed but more artistic, missed the delicate canaliform detail to make a speaking portraiture of the whole. Amid the remarkable continuity of progression here shown, in which each map will be seen to be at once a review and an advance, we may, nevertheless, distinguish 3 stages in the perception of the phenomena. Thus we may mark 1. A period of recognition of larger markings only, 1840 to 1877. 2. A period of detection of canals intersecting the bright regions or lands, 1877 to 1892. 3. A period of detection of canals traversing the seas and of oases scattered over the surface, 1892 to 1905. Each period is here represented by 4 charts, and each expresses the result of a more minute and intimate acquaintance with the disk than was possible to the one that went before. To realise, however, how accurate each was according to his lights, it is only necessary to have the seeing grow steadily better some evening as one observes. He will find himself recapitulating in his own person the course taken by discovery for all those who went before, and in the lapse of an hour live through the observational experience of 60 years in much the same way that the embryological growth of an individual repeats the development historically of the race. 2 verses of Ovid, which the poet puts into the mouth of Pythagoras, outline with something like prophetic utterance the special discoveries which mark the 3 periods apart. Ovid makes Pythagoras say of the then world, Vidi ego, quod fuerat quondam solidissima tellus esse fretum, vidi factus ex aequore terras. Ovid, Metamorphoses, 15, 262. Where once was solid ground I've seen a strait, lands I've seen made from out the sea. True as the verses are of earth, the poet could not have penned them otherwise had he meant to record the course of astronomic detection on Mars, for they sound like a presentiment of the facts. The surface thought at first to be part land, part water, the land next seen to be seamed with straits, and lastly the sea made out to be land. Such is the history of the subject, and words could not have summed it more succinctly. Vidi ego quod fuerat quondam solidissima tellus esse fretum rings like Schiaparelli's own announcement of the discovery of the canals. Indeed, I venture to believe he would have made it had he chanced to recall the verse, So Vide factus ex aequore terras tells what has since been learned of the character of the seas. Of the three periods, the first was that of the main or fundamental markings only. It came in with Beer and Mädler, the inaugurators of areography. That they planned and executed their survey with but a 4-inch glass shows that there is always room for genius at the top of any profession, and that instruments are not for everything in its instrumentality. Up to their day, the reality of the planet's features had been questioned by some people, in spite of having been certainly seen and drawn by Huygens and others. Beer and Mädler's labours proved them permanent facts beyond the possibility of dispute. The second period was the period of the discovery of the now famous Canals, a new era in the study of Mars, opened by Schiaparelli in 1877. Unsuspicious of what he was to stumble on, he seized the then favourable opposition to make, as he put it, a geodetic survey of the planet's surface. He hoped this undertaking feasible to the accuracy of micrometric measurement. His hopes did not belie him. He found that it was possible to measure his positions with sufficient exactness to make a skeleton map on which to embody the markings in detail, and thus to give his map vertebrate support. But, in the course of his work, he became aware of hitherto unrecognized ligaments connecting the seas with one another. Instead of displaying a broad unity of face, the bright areas appeared to be but groundwork for streaks. The streaks traversed them in all directions, tessellating the continents into a tilework of islands. Such mosaic was not only new, but the fashion of the thing was of a new order or kind. Straits, however, Schiaparelli considered them and gave them the name canali, or channels. How unfamiliar and seemingly impossible the new detail was, is best evidenced by the prompt and unanimous disbelief with which it was met. Unmoved by the universal scepticism which rewarded what was to prove an epoch-making discovery, Schiaparelli went on, in the judgment of his critics, from bad to worse, for in 1879 he took up again his scrutiny of the planet, to the detecting of yet more particularity. He reobserved most of his old canals, and discovered half as many more, and as his map shows, he perceived an increased regularity in his lines. In 1881 to 1882 he attacked the planet again, and with results yet further out of the common. His lines were still there, with more beside. If they had looked strange before, they now appeared positively unnatural. Not content with a regularity which seemed to the sceptics to preclude their being facts, he must needs see them now in duplicate. To the eyes of disbelief, this was the crowning stroke of factitiousness. In consequence, no end of adverse criticism was heaped upon his observations by those who could not see, but, curiously enough, what did not attract attention, the blindness of the critics was as much mental as bodily, for they failed to perceive that the very unnaturalness which seemed to them to discredit his observations really proved their genuineness. His discoveries were so amazing that any change in strangeness simply went to confirm the universal scepticism and clouded logic. Yet, properly viewed, a pregnant deduction stands forth quite clearly on a study of the maps. On comparing maps 5, 6 and 7, an eye duly directed is struck by a difference in the aspect of the lines. In his first map, the canals are depicted simply as narrow, winding streaks, hardly even roughly regular, and by no means such departures from the plausible as to lie without the communicatory pale. Indeed, to a modern reader prepared beforehand for geometric instruction, they will probably appear no canals at all. Certainly the price of acceptance was not a large one to pay, but like that of the Sibylline books, it increased with putting off. What he offered the public in 1879 was much more dearly to be bought. The lines were straighter, narrower, and in every way less natural than they had seemed 2 years before. In 1881 to 1882, they progressed still more in unaccountability. They had now become regular rule and compass lines, as straight, as even, and as precise as any draftsman could wish, and quite what astronomic faith did not desire. Having thus donned the character, they never more put it off. Now this curious evolution in depiction points, rightly viewed, to an absence of design. It shows that Schiaparelli started with no preconceived idea on the subject. On the contrary, it is clear that he shared to begin with the prevailing hesitancy to accept anything out of the ordinary, nor did he overcome his reluctance, except as by degrees he was compelled, for the canals did not change their characteristics from one opposition to another. The eye it was that learned to distinguish what it saw, and the brain made better report as it grew familiar with the messages sent it. In other words, it is patent from these successive maps that the geometric character of the canals was forced upon Schiaparelli by the things themselves, instead of being, as his critics took for granted, foisted on them by him. We have since seen the regularity of the canals so undeniably that we are not now in need of such inferential support to help us to the truth, but too late, as it is, to be of controversial moment, the deduction is none the less of some corroboratory force. With the third period enters what has been done since Schiaparelli's time, for that master was obliged, from failing sight, to close his work with the opposition of 1890. In 1892, W.H. Pickering at Arequipa was the chief observer of the planet and made two important discoveries. One was the detection of small round spots scattered over the surface of the planet and connected with the canal system. The other, the perception of what seemed to him more or less irregular lines traversing the Mare Erythraeum. Both were notable detections. The first set of phenomena he called lakes, the second river systems, sometimes schematically canals, but without committing himself to canaliform characteristics, as his drawings made clear. The same phenomena were seen at that opposition at the Lick by Shea Burrell, Barnard, and others, and called streaks. These discoveries took from the Maria their supposed character of seas, a most important event in knowledge of Mars. The next advance was the detection at Flagstaff in 1894 of their canaliform characteristics by my then assistant, Mr. Douglas, who in place of the irregular streaks and river systems of his predecessors found the seas to be crossed by lines as regular and as regularly connected as the canals in the light regions. To him they appeared broad and ill-defined, but so habitually did to him the canals in the light areas, while for directness and uniformity the one set showed as geometrically perfect as the other. All the dark Maria of the southern hemisphere he found to be laced with them, and that they formed a network over the dark regions, counterparting that over the light. Still more significant was the fact that their points of departure coincided with the points of arrival of the bright region canals, so that the two connected to form in its entirety a single system. After the publication of his results, Lowell Observatory Annals, Volume 1, 1895, Schiaparelli identified some of those in the Syrtis with what he had himself seen there in 1888. Memoria 6, 1899, though his own had not been sufficiently well seen of him to impress him as canals. Of other additions to our knowledge since made by the writer the present book treats, as also of the theory they originally suggested to him, and which his later observations have only gone to confirm. End of chapter 3.